Welcome back. This is the second part of the quantum number explanation. In the first part, we learned how to do the first two quantum numbers, and they were the principal quantum number, which was based on the row number, and we did learn how to do the orbital quantum number, which was based on the section. If you have not watched the first part screencast, you will need to watch it now before getting into part 2, because I will reference it as part of the explanation here. Okay, so when we left off in part 1, I gave you an assignment of doing these 10 elements and finding the first two quantum numbers. Here are the answers if you would like to look them over and check yours in case we didn't do them in class. Take a minute and do that now. Here is the study guide that we built with part 1 of the quantum numbers. So if you can't find yours and maybe you want to edit it or you need to rebuild it, here is what we have so far on our study guide. You will remember that you have some numbers down the side. You have numbered 1 through 7. You have relocated helium over here. And you probably have a star and a smiley face showing where these particular elements fit into the periodic table. All right, so the third quantum number is called the magnetic quantum number, and it has the symbol M. This one is talking about the orientation in space of a particular set of orbitals. So in the last one, in the first part of the quantum numbers, we did energy level and we did shape. So we talked about what shape the orbitals take on, but within those orbitals, you have some sublevels. And what is going on is that electrons can occupy a sublevel with they can occupy an orbital with 2 electrons, and they have to go in a specific path in order to not collide with others. And we are going to be looking at their orientation. So if you want to think of it as in a coordinate plane, you have X, Y, and Z orientation. You have up, you have to the side, and then you have out towards you, if you recall that from math. So the numbers that we're going to deal with are going to label those paths in an electron. So we are going to have numbers that are going to count a range. Now range is going to be our tag word that is going to help us understand what to do when we're doing quantum numbers. You might be like, well, I can't remember the third one. And I'll say, well, did you count the range? You're going to count the range twice. Okay, and the range will depend on what section of the periodic table you're looking for. You will always go from negative to positive, and we're going to include 0 in our range. Here is an example. If you look at the first row of the P section of the periodic table, you see boron, carbon, nitrogen, oxygen, fluorine, and neon. That section has a orbital shape number of 1. So it's assigned P, and we know that that's a 1. So what you do is you take that number, and you are then going to work from the negative of that number the whole way up to the positive of that number. So we're going to have number options between -1 and +1 in this case, and we include 0. You will start at the beginning of the row, and you will count all the numbers between your range here. So we're going to count. We're going to go -1, 0, 1. And we went the whole way through our range, and now we're going to repeat -1, 0, 1. If you do this correctly for the section that you're in, it will always end up even. You will not have any elements left over, and you will end at the very end of your range after the second time. I'll show you an example. So I just said that I would do an example, and I will after we label our study guide. If you have your study guide handy, we are going to put some new information on it. We are going to write the third quantum number, which is called the magnetic quantum number. And this one shows the orientation. And our code word is range. Okay. This is the information we already have on our study guide. We have S section, we have P section, we have D section, we have F section. Now, what I'd like you to do is to take one of the rows in the P section, either the bottom one like I have labeled here, or the top one, or above or below it, and I want you to count, I want you to write in this range number. And so we go -1, 0, 1, -1, 0, 1. Okay, I have seen other students in the past go ahead and count off all the ranges for all the sections, and that's fine, that's your choice. But I don't think you need it. I think after a time you're just going to be able to look at the number and figure out what the number it is. So I said I would help you with another example. Let's say our element is in this section. If we have this section is a 2, we're going to start over here and count -2, -1, 0, 1, 2, -2, -1, 0, 1, 2. And you're going to count the whole way over until you land on your particular element that you're looking for. Now, I don't have the boxes labeled, so we don't know exactly what we're talking about. But we would count over until we got to the element we wanted, and the number that we stop with is our third quantum number. Alright, so we are at our fourth quantum number, and our fourth quantum number is probably the easiest one to come up with, and it is called the spin quantum number, and it is abbreviated with an S. Sometimes I've seen it an M sub S for spin, and it's going to indicate the direction of spin. Now, you have two choices. You can be positive 1/2 or you can be negative 1/2. You do have to label the positive or negative, and you will need to have a fraction. You may not do a decimal. You'll have to keep it as a fraction. The graphic that I've provided you with here is just a recap of the four quantum numbers, so maybe that'd be helpful and it helps you remember. Alright, so we need to label our last layer. So we have spin quantum number, and that is going to be our spin direction. And I don't really have a little helpful reminder. If you want to write positive or negative or positive, that's fine. Here's the deal. When you're doing the quantum numbers, you count through a range once, and then you count through a range again. So the first time you count through that range, your quantum number is going to be positive 1/2 for the fourth quantum number. And then the second time, it's going to be negative 1/2 for the quantum number. So all of these first three, -1, 0, 1, are all going to have a fourth quantum number of positive 1/2. And then the second time through, they're all going to have negative 1/2. And that is the same in any section. When you are working through over here in the S's, so here you can have 0 or you can have 0. And the first time is going to be positive 1/2, or it's going to be negative 1/2. Okay? So now you can put it all together. If you have an element right here, you know that it's going to be energy level or row of, it's normally in the 7th row, but we're going to subtract 2, so it would be 5. And then we know that it is in section 3, and it is the first element, so our range is going to be -3, and then it has a positive 1/2. So that is the quantum number set for that element right there. As with anything, we have some rules. So the first rule that you're going to notice for this chapter, and we're going to use with every concept that we learn in it, is called the Pauli exclusion principle. And Pauli exclusion principle says that you have unique elements, so you have unique set of quantum numbers. That no two elements are going to have the same set of quantum numbers. And that makes sense. Each element is in a different space on the periodic table. And if we're counting on the periodic table, it will have a different set of numbers. We will use Pauli exclusion principle with all the other concepts that we learn as we progress, things like quantum orbital diagrams and electron configurations. Alright, so to go in reverse, we are going to need to look at the quantum numbers. For instance, if we have 4, 0, 0, -1/2, you need to look at the first two quantum numbers, because that tells you the row number and the section. So when you're in the row number and the section, you are going to have a better ballpark, you're going to have a more narrow field in order to identify what element you're dealing with. So once you've figured out what row and section you're in, you're going to need to remember to add 1 or 2 if you're in one of those sections where you have to normally subtract. We're going in reverse, so we have to do the reverse of the math. Okay. You're going to count over to the range either the first or second time depending on the half. So as you can see, our half here is negative, so that's our second time through the range. So we're going to count over to 0 the second time and we would learn that this element is calcium. Here's some more practice. Remember, we did these elements already, so we know the first two quantum numbers for these. I would like you to go ahead and find the last two quantum numbers and finish out this practice, and we will go over these in class the next time that we all meet.